and the inverse cosine. Those are inverse functions. So what you're actually left with number one, believe it or not, is just 1/2, because the cosine here and the inverse cosine, they sort of cancel each other out, and then you're left with just 1/2. All right, so that's how to do that. This one right here, this is essentially saying the cosine of what angle equals 1/2. The cosine of what angle equals 1/2. So what the teacher, it seems like the teacher wants my student to do is to set up some kind of a triangle. Maybe here's the angle right here, and we're curious, the cosine of what angle would be 1/2? Well, we both know that cosine is adjacent over hypotenuse, so that would be 1/2. And the question is, you know, which angle would result in this being 1 and 2? All right, or you could think of it as, you know, 1x and then 2x. Well, you might recall that that is a special right triangle that is called a 30, 60, 90, and in this case the 30 would be right here and the 60 would be right here. And the way that I know that is because this is the hypotenuse and it's twice this leg. Okay, so the short leg of a 30 degree 30, 60, 90 triangle is, you know, a certain amount, and then the hypotenuse is always twice that. Okay, and then the longer leg is always this. So this is a decent time to actually just draw all of these special right triangles. So that's a 30, 60, 90 from that point of view. A 30, 60, 90 might be worth drawing from this point of view as well, where that's A, that's 2A, and that is A radical 3. And finally, we could also draw the 45, 90 as well right here, because that will most likely come into play on this worksheet as well. I'm kind of all over the place, but I decided to do this video on the fly, so kind of winging this one. But nonetheless, when it comes to this problem, it's like the cosine of what angle is 1/2? Well, that would be the cosine of 60 is 1/2. Okay, and the way that I know that is because here's the angle right here, and it corresponds with this situation where this short leg is, you know, a certain amount, and the hypotenuse is twice that amount. So we know that this right here is 60. So really, what this problem is asking is, what is sine of 60? What is sine of 60? Well, the good news is we sort of have, you know, a nice 30, 60, 90 here to work with, and here's the 60 right here. We both know that, or well, we all know that sine is opposite over hypotenuse, so that would be A radical 3 over 2A, and then the A's would cancel, and that would leave us with this radical 3 over 2. All right, radical 3 over 2. So the answer to that is most definitely radical 3 over 2. Okay, first, you know, sine 60, that's radical 3 over 2. Anyway, hopefully that makes sense to my student. This is the sine of what angle equals 1. So this is a beautiful example of how the unit circle would actually be better, but you know, it's kind of a weird question. Let's say we do take into account what my students seem to have been doing. On a unit circle, you know, if it was on a unit circle, the hypotenuse itself would be 1 unit long. And, you know, sine is opposite. Sine of any angle is really opposite over hypotenuse. So in order for the sine of this angle to be 1, then the opposite and the hypotenuse need to be the same. All right, so that's a way of thinking about it. So the opposite and the hypotenuse has to be the same. Well, this is the hypotenuse, and it's, you know, 1 if it was the unit circle. And in order for the quote-unquote opposite side to be the same, well, this must be also the opposite side. So therefore 90 degrees is the answer. because the opposite over the hypotenuse equals 1. So maybe that's a way of thinking about it. So that's 90 degrees right there. Again, I would much prefer looking at the unit circle for that. Alright, so obviously this is like the tan of what angle is this? Well, let's find out what this is first. This is really sine of 90, and we already, just discovered that the sine of 90 is 1. In fact, we kind of just got that from this problem, because it's like the sine of what angle is 1? Well, 90 degrees. So the sine of 90 degrees is 1, right? So it's like inverse tan of 1 at the end of the day. So this is essentially a question saying the tan of what angle is 1, right? So that kind of lends itself to the special triangle situation as well. Let's say here's the angle in question, and we know that the tan of any angle is opposite over adjacent, right? The tan of any angle is opposite over adjacent. In fact, I'll write that. Tan of any angle equals opposite over adjacent. Well, in order for this to be 1, well, the opposite must be equal to the adjacent. So it must therefore be the case that this side, which is the adjacent, and this side, which is the opposite, are the same. And that should immediately make you think of the 45, 45, 90 special right triangle, because it's like the only right triangle that happens to be isosceles, and that's right here. Okay, now I really should have labeled it, so let me label that as 45, 45, 90. Okay, so when we are looking at this problem and it's asking the tan of what angle equals 1, that's essentially saying what angle is such that the opposite over adjacent equals 1. Well, that's definitely 45. Okay, 45 degrees. Okay, so this one is the tan of what angle is radical 3 over 3. So if we were to kind of draw that, let's just draw like a normal looking triangle. And here's the angle in question. And again, tangent is opposite over adjacent. So in this case, it's like the tan of what angle is radical 3 over 3. Well, we can sort of suspect that since this is not a 45, 45, 90, and we know that because this is not the same as that. If it was 45, 45, 90, then these would be the same. These are clearly different. So we know it's one of these two, right? We know that it's either, this guy where the, angle happens to be 60, or it's this one where the angle happens to be 30, right? Now, I'm going to say that even though we got this radical 3, which kind of seems like it's this thing, it's actually not, because if this side was this side, then the A in this case would be 1. There'd be an invisible 1 in front of there, and then this A should be 1. So that's not 1 right there, okay? So we know that this triangle does not correspond with this triangle. This triangle corresponds with this triangle, okay? That's a way of kind of using process of elimination and just like narrowing it down, all right? So we know that that for sure is 30. Now, in case we're not clear about that, we could always set this 3 equal to A radical 3 and then find out what A is. And I will tell you right now, if we do that, 3 would force it to be equal to A radical 3. And we would soon discover that it would be 3 over radical 3, which at the end of the day simplifies to 3 radical 3 over 3, also known as radical 3, because these 3's would cancel, okay? And then therefore A would be radical 3. Well, what do you know? There it is, radical 3 corresponding with A. So you could go through all those motions, or you could simply realize that this triangle absolutely doesn't correspond with this, so it's got to be one of these two, and it's definitely not this one, because again, there's an A in front of the radical 3. Well, in this case, A would be 1, which means that this should be 1. because according to this, A is down here. It's not 1, so that leaves only one option. We know that this one is corresponding with this model, and therefore 30 degrees matches that, and therefore the tan of what angle equals that? Well, it's 30 degrees, right? And then it's like, well, what's tan of 30 degrees? Well, that's going to end up being radical 3 over 3, okay, again. At the end of the day, this is somewhat similar to the first one, where it's like the inverse function and the function, so you end up getting radical 3 over 3 as the answer. So, you know, that's a way of cutting to the chase even more so, but I did want to go over the strategy that the teacher seems to be focused on. So now we have arc sine, that's basically inverse sine, so it's like the sine of what angle is 1/2? Well, I don't know. I mean, let's draw a triangle, right? Sine of what angle is 1/2? We'll use this as our quintessential triangle. So, you know, sine of this angle is 1/2, so sine is opposite over hypotenuse, so we're going to make this like 1 and this 2. So we have a case where the hypotenuse is 2 times the leg over here. Now, you know, we can suspect it's probably not this, right? Because this is a times radical 2. This is not 1 times radical 2 over here, right? So we could, once again, not worry about this one and narrow it down to either this one or this one, right? Well, this one is the triangle that is such that the hypotenuse is 2 times the short leg, or this leg, I should say. So we know that that's 30, right? So at the end of the day, we know that when they say arc sine of 1/2, what they really mean is 30 degrees. So the real question is, what is cosine of 30? For that, we can once again use the special triangle right here. So cosine of 30, well, that's adjacent over hypotenuse. That's going to be a radical 3 over 2a. So that's going to be radical 3 over 2. Radical 3 over 2. Okay. So you always want to start inside the parentheses. So this is like the sine of what angle is radical 3 over 2, and this is the cosine of what angle is radical 3 over 2. So let's see, did we do anything like this before? It looks like no. I was kind of hoping that we would have an arc sine of radical 3 over 2 over here, but we don't. So focusing only on the arc sine of radical 3 over 2, what we have on our hands here is once again relying on our lovely triangle. You know, the sine of what angle would be radical 3 over 2? Well, that's opposite over hypotenuse, so that's radical 3 over 2 right here. And let's see, so this one actually does correspond well with that, because if this side corresponded with that side, then the A would be 1, right? And then you'd have a 1 down here, and this hypotenuse is 2 times that, right? Because you have a 1 down here, and the hypotenuse is 2 times that. So this triangle actually corresponds well with that triangle. So that's definitely 60. So you might want to write that in there. The arc sine of radical 3 over 2 is really just 60. And then it's minus, you know, the arc sine of the arc cosine, or the inverse cosine of radical 3 over 2. Well, you know, I think probably most of us are already suspecting it's going to be the other one. But cosine of what angle is radical 3 over 2? Well, that's adjacent over hypotenuse, so that's radical 3 over 2, right? So that corresponds with this one, right? Because there's an invisible 1 here, and there should be a 1 right there, and then 2 times that short leg is this, and that corresponds perfectly with this. We have a side length here, 2 times that side length is that, so that's definitely 30 degrees right there. So really what we're dealing with is 60 minus 30, and it's the tan of that, so that's clearly the tan of 30, And that's going to be easy enough to find, because we could look right here. The tan is always opposite over adjacent, so that's going to be a over a radical 3. Now let's kind of work that out right now. A over a radical 3, the a's are going to cancel, and you're going to be left with 1 over radical 3, which after going through the motions would be radical 3 over 3. Okay, so that's radical 3 over 3. And in case you're not sure what I did there, I rationalized the denominator. So I multiply the top and the bottom by radical 3. 1 times radical 3 is just radical 3. Radical 3 times radical 3 is just a 3. And now you're good to go. So mathematicians or math teachers hate it when you have a radical in the denominator. So they might ask you to rationalize it this way so that your final answer looks like that. So that's that. Let's see. So looking at this one. So yeah, it's going to be something minus pi over 4. Now my student might recall pi over 4 is really 45 degrees. Okay, so we'll just keep that in mind. The question is, the cosine of what angle equals radical 2 over 2? The cosine of what angle is radical 2 over 2? Once again, we're going to use our model triangle. And we're going to remember that cosine is adjacent over hypotenuse, right? Adjacent over hypotenuse. So in this case, it's radical 2 over 2. And then the question is, which of these would correspond with that? Now, the presence of the 2 and the radical 2, it kind of deviates away from the radical 3 stuff. So it should kind of make you think about this, okay? It should make you think about this. Now, at the end of the day, it actually is this, all right? Now, in case you're not clear why, let's imagine that it is, and that would make this radical 2, right? Well, according to this, the hypotenuse is whatever the leg is times radical 2. Well, this should be whatever the leg is times radical 2. So let's see what the leg, which is radical 2, times radical 2 is. Well, what do you know? That's just a 2. Well, that is right there, okay? So once again, according to this, the hypotenuse will be whatever the leg is, a times radical 2. So when I multiply this leg, a times radical 2, what do I get? 2, okay? So we know for sure this is 45 degrees. So at the end of the day, this is really sine of 45 minus this, which is 45. And then it's really sine of 0. So what's the sine of 0 degrees? Well, that would be 0. Right? Because the sine is opposite over hypotenuse. So if this is if the angle is 0, then it's not even a triangle, right? It's just like a straight line. So yeah, the sine is 0. So that is that one. Looking at this one right here, this is saying the tan of what angle is radical 3. So let's see. So once again, with the special triangle right here, the tan of what angle is radical 3? So tan, as we know, is opposite over adjacent, so that would be radical 3 over 1, right? And then the question is, does this thing correspond with this one or that one? Well, it looks kind of like this one, right? Because it's like radical 3, there's a radical 3 there. A means the number that's being multiplied to radical 3. Well, there's an invisible 1 being multiplied times radical 3 right there. And then, whatever that number is, it should be down here. Well, guess what? It is. It's down here. There's 1 right there. So this is 60 for sure. All right, that's 60. So I could write 60. And it's going to be minus. It's like the sine of what angle is 1/2. Let's see. Did we do that before? The sine of what angle is 1/2? We did it before. So the sine of this angle, that's 30. So that's going to be 60 minus 30. I'm big on saving time. I don't want to repeat myself. So it's really cosine of that, which is really cosine of 30. And cosine of 30. Let's see, did we do that at all? I don't think so. So anyway, that's easy enough. Here's 30 degrees. Cosine is adjacent over a hypotenuse. So that's going to be a radical 3 over 2a. A radical 3 over 2a. And then canceling out the a's gives me a radical 3 over 2. Right? Radical 3 over 2. That's the answer to that. Okie dokie. So we want to verify this. First time we're seeing the secant stuff, which is not necessarily too fun. But one step at a time. The tan of what angle equals 1? Well, we already kind of worked on that. That's 45. The cosine of what angle is radical 3 over 2? Well, guess what? We just did that in the previous problem, right? So that's going to be plus 30 equals. The sine of what angle is 1/2? Did we do that before? I think we did. It seems familiar at least. So let's see. The sine of what angle equals 1/2? Well, according to this, it was 30, right? So that's going to equal 30 plus, and the big question is this thing 45, right? Because if it is, then we have verified this, right? Because 45 plus 30 equals 30 plus 45, right? So the real question is this 45? And if it is, then we have verified the equation. So the secant of what angle is radical 2? Now, there's sine, there's cosine of theta, there's tan of theta, right? Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tan is opposite over adjacent, and cotan is easy to remember. That's just the flipped version of tan. And this one gets a little tricky where it's like there's secant and cosecant. Now you would think cosecant would be with the cosine because it kind of sounds the same, but it's actually not. Cosecant is with the sine, so that's cosecant theta, and it's flipped, h over o. And then secant is the reciprocal of cosine, so that would be h over a, right? So these are things that are worth memorizing at a certain point. Nonetheless, this is what we're focused on right now. And the question is, the secant of what angle is radical 2? Well, I'm just going to draw, a nice little thing. And if we're going to do the secant of this angle, it's going to be the hypotenuse over the adjacent. So that's going to be radical 2 over 1. So the secant of this angle is hypotenuse over adjacent, also known as radical 2. All right, and by the way, I knew there's a 1 because there's a little 1 underneath this radical 2. Well, clearly, this is a 45, 90, because if this was 1 right there, then you'd have 1, 1, and then 1 times radical 2. So that's 45 for sure. All right. So yeah, there is no question about it. The inverse secant of radical 2 is equal to 45. So this is verified. Now, as far as what your teacher needs to see, in order to know that you know what the heck you're doing, you might want to write something like this, right? To show your teacher that you know what secant means. It's hypotenuse over adjacent. You might want to draw a little triangle like this where you put the radical 2 in the hypotenuse and you put a 1 as the adjacent, and then you could be like, that looks like a 45, 90, and therefore this is 45, and therefore this is 45, and therefore you are done. Okay, so that might have been confusing. Okay, I'm trusting for my student it's not that confusing because it's not like she hasn't been doing stuff like this relatively recently, so a lot of this stuff should be somewhat fresh. Okay, for those of you at home, of course, if you have any questions, comment below, and I will talk to you.